Hey, what's going on, guys? In this video, we will set up React with Webpack, TypeScript, and Babel from scratch without using Create React App CLI. I've done this same video a few months ago, and I realized that I had been writing deprecated code, and some of the packages that I used at the time are no longer supported in 2023. So I just wanted to stay up to date and have a nice development environment set up. So in order to do this, we'll need to first make sure that we have nodeJs installed on our computer. So if you have not installed, just go to nodejs.org and download the installer, and this will also automatically install npm, which is a node package manager, and that will let us install and uninstall npm packages. If you are wondering what nodejs is, it clearly tells us that it's a JavaScript runtime environment, and that just means that nodejs provides additional functionalities and additional features so that JavaScript can work both on client side as well as on the server side. Because JavaScript was initially meant to run only on the client side and not on the server side, it was basically used to provide interactivity to the website initially. But after the evolution of technologies like Node.js, we can actually run JavaScript on the server side also and as a backend programming language. So after we have Node.js installed, create a folder anywhere on your computer, and you can name it anything that you want. I have named it React from scratch in my case, and then I have imported that folder into VS Code. And I'm currently in my project folder. So the first thing we'll do is we'll need to make sure that we actually have Node installed on our computer, and we can do that by typing node-v. And as you can see that I have Node version 18.14.2 installed. So let's also make sure that we have npm installed. So we can do npm-v, and you can see that I have npm version 9.5.1 installed on my computer. So after we have node and npm installed, we can go ahead and initialize this project folder as a node project. So right now it is nothing but just a computer folder. So we'll need to initialize this project folder as a node project. So we can do npm init, and I'll also type a -y flag in there so that it does not ask me any question in the command line. So what this will do is that it will create a package.json file. So as you can see that the package.json file is already created with some of the default configuration. So after we have package.json file, we can now actually start installing some of the packages that we need. So there are mainly 4 major packages that we need. That is, we need React in order to build front-end UI components. And the second package we need is Webpack, which is a module bundler. So what Webpack will do is it will look at all the files that we have on this project folder, and it will create a single file which is called a bundle, and that file will be deployed to production. And the third package we need is Babel. So Babel is basically a JavaScript compiler. It will convert newer version of JavaScript into older version of JavaScript so that the newer JavaScript code that we write can actually be run on older version of the browsers as well. So let's say that if you are writing arrow functions, which is only available in ES6 or later version of JavaScript, so Babel will convert that ES6 into older version of JavaScript so that the arrow functions can work in older browsers as well. So without Babel, you will not be able to do this. Of course, there are some alternatives, but Babel is one of the popular ones out there. So we'll also be installing Babel. And the fourth package that we need is TypeScript. So if you don't know what TypeScript is a programming language which is basically a superset of JavaScript. So it's built on top of JavaScript. So whenever you write TypeScript code, browsers do not understand TypeScript code, so TypeScript code does have to be transpiled to JavaScript code in order for browsers to work. So TypeScript is only mainly used for type checking. And if you are working on a smaller project, or maybe just a simple website, we do not need TypeScript at all because it just makes our project more complex. But let's say that if you are building a complex library, or especially if you are working with multiple team members, then TypeScript can actually make your job a lot easier. So that's the 4 packages that we need. So let's go ahead and install these packages. So we will first install React and React DOM, and we will install this as a dependency and not as a dev dependency because we need React and React DOM to build UI components. So we need to install React and React DOM as a dependency. So I'll do npm install React and React DOM. After we install React and React DOM, we can see a few changes has occurred in our package.json file. We created a new object called dependencies, and then that dependencies object has React library and React DOM library. So we have the same version of React and React DOM, that is 18.2.0. So we need to make sure that we have the same version of React and React DOM, or it's not going to work and you're going to get errors in the future. And you also see that there's a new folder called node modules that's created in our project folder, and inside that node modules folder you'll see 2 packages. That's React that we just installed, and you'll also see a React DOM package that we just installed, and you'll also see these other packages. You might be wondering, where did these folders or where did this package come from? The thing is, whenever we install React and React DOM, because React and React DOM libraries, they might have their own dependencies as well. So whenever you install React and React DOM, it is going to install other packages or dependencies of React and React DOM libraries. And the other thing you might have noticed is it also created a package lock.json file. So this is basically a file that keeps track of the dependency tree. So whatever packages you install, it basically keeps track of those packages and also the dependency of those packages. So if you go through this, you can see that it actually contains all the package names like the scheduler, React DOM, React, and lose MB5 JS tokens. So it actually contains all the packages that we install and also the dependencies of those packages. So after we have React and React DOM installed as a dependency, we can go ahead and install other packages, and these packages will actually install as a dev dependency and not dependency, because we only need these packages for development and not in production. So we will install Babel. So we'll do npm install, we'll install Babel core, and we'll also install Babel CLI, and we'll install Babel preset env, and we'll install Babel's preset for TypeScript, and we'll also install Babel's preset for React, and we'll also need Babel loader in order to load JavaScript and JSX files. So we'll do Babel loader. So those are all the Babel packages that we need. So let's go ahead and install Webpack too. So we'll need Webpack, and let's install Webpack CLI so that we can run Webpack on the command line. Let's also install Webpack dev server so that we have a development server to work with. And we'll need to install TypeScript, and we'll also install TS loader. So TS loader is used to load the TypeScript files, that is the TS or TSX files. So we'll install TS loader, and we'll also install types for React. So this is provided by TypeScript, so we can do type/React. And in order for styles or CSS to work in our application, we also need two packages, that is style loader and the CSS loader. So let's go ahead and install that as well. And let's actually make sure that this is installed as a development dependency and not as a dependency, because again, we do not need all these packages in production. So we'll do npm install -save -dev. So I think that's all the packages that we need. If I missed any of the packages, then we can always come back and install those packages later. But let's go ahead and install all those packages. So once we install all those packages, you can see that a few changes has occurred. So we have a new object called a development dependency, and these are the dependencies that will only be used in development. And you can see that all these packages we have installed has come up in these dev dependencies. And you'll also see that the package lock.json file has gotten much bigger because we installed all these packages, and all these packages had their own dependencies also. So this package.json file is just infinitely too long. If you also see node modules folder, again, there are tons of folders in node modules now because we install all these packages, and those packages have their own dependencies. So after we install those packages, we can actually now start configuring Webpack and TypeScript and Babel. So in order to do that, the first thing we can do is let's configure TypeScript. So in order to do that, I will create a new file in my project folder in the root directory called tsconfig. And this is a JSON file. So once we have that tsconfig.json file, we can actually start writing the TypeScript configuration for our project. In this tsconfig.json file, we'll specify some of the TypeScript configuration for our project. We will specify some of the rules for strict type checking. We'll also enable JavaScript and JSX, and we'll also include and exclude some of the folders. So we will basically exclude the node modules folder that TypeScript does not need to know about, and we'll include a src folder that we have not created yet. So let's go ahead and start writing this configuration. So I'll open a curly braces there, and the first thing I will specify is a compiler options, and that will be an object. And inside that, I will set a property called noEmit, and I will actually set that to true, and we'll set allow unreachable code to be false. And this will ensure that the code paths that cannot be reached will be flagged as errors. And the other option we'll specify is exact optional property types. So we'll specify that as true. So this will ensure that the optional properties have the correct type and are not accidentally used as a required property. And we'll also set no fall through cases in switch to true. And this will ensure that any switch statement that we write with unintended fall through behavior will be flagged as errors. And we'll also set no implicit this to true. And this will ensure that the this keyword in JavaScript has a valid type. and we'll set no unused locals to true, and this will ensure that any unused variables that we write, they will be flagged as errors. And same with the parameters, so we'll say no unused parameters. We'll also write true, so that if there's any parameters that we specify and we don't use it, it will be flagged as error. And we'll also set no implicit any to true, so this will ensure that any variable with an implicit any type will be flagged as error. And we will also specify no implicit returns to true, and this will ensure that any functions that does not have a return statement will be flagged as error. And we will specify always strict to true. This will ensure that our code is always run in a strict mode. And we'll set strict blind call apply to true in order to ensure that any methods will be called with the correct number of argument and with correct types. And we'll also set strict function types, so that any functions that we write will be called with the correct number of parameters and correct type. And we'll also specify strict null checks. We'll set that to true, and this will ensure that variables are not assigned a value of null or undefined, and if they are, it'll throw an error. And we'll also specify strict property initialization to true, and this will ensure that any class properties are initialized before use. And then we'll specify JSX as React, and this will specify the JSX syntax mode. And then we'll set allow JS to be true, and this will enable TypeScript to compile both the JavaScript files and also the TypeScript files. And we'll also set check JS to true, and this will enable TypeScript to check not only the TS files or the TypeScript files, but also the JavaScript files as well. And we will specify isolated modules to true to ensure that each file is compiled in isolation without relying on other files. So these are just some of the most common and basic TypeScript configuration. There are many other configurations that you can set. So let's say, for example, sometimes you might not want TypeScript to throw an error when you specify a property as or a type as any. You might not want TypeScript to throw any error, so you can specify that as false. And there are just other configuration options. So if you just go to the TypeScript documentation, they have it nicely laid out here. So these are all the options that is available, and for the purpose of this video, going through all the options is very time consuming, so we'll not be doing that. But if you go to typescriptlang.org and /tsconfig, which is a file that we are working on, it provides all the options or all the configuration that you can set. So but for now, I think that will be enough. And before we wrap up with this file, we also need to specify the include property, so that TypeScript knows what files to include and what folders to include. So in this case, we will tell TypeScript to check for all the files and folder inside the src folder. So we will include src and just any folders inside that src folder. So this will basically check the src folder and any subdirectories inside that src folder. And we'll also specify the exclude option, and we'll set that to node modules, because we do not want TypeScript to look at our node modules folder. So that should be it for the TypeScript configuration. And you can always go through TypeScript documentation and go through, if you want to specify more options, you can always do that. And it's a personal preference, because TypeScript is only used in development. It's just supposed to make a developer's job a little easier. So you can configure TypeScript however way you want, but these are just the basic and some common TypeScript configuration that needs to be included in a project. After the TypeScript configuration, we can now start configuring Webpack for our project. So in order to do that, I will create a new file in the root directory called webpack.config.js, and in this webpack.config.js file, we'll specify Webpack configuration. So the first thing I'm going to do is I will declare a variable called path, and that will require a path module, which is built into nodeJs, so we do not need to install this. And then I'll do module.exports, and this will be an array of object. And the first thing we will specify is the entry point. So this will actually tell Webpack to look at this file and create a bundle. So I do not have this folder or the file yet, but I will create a folder called src. And then I will also create a folder inside that called client, and inside that client folder I will have a file called index.tsx. So this will basically be the entry point. So Webpack will look at this file and then build our bundle. So after the entry, we can also specify mode as development. So whenever you specify mode as development and you build your project, then Webpack will have a lot of comments in the bundle file, so that you can debug your code. But if you specify mode as production here, then Webpack will not include any of those comments, and you'll just have a clean copy of the bundle. But let's just set it to development for now because we are in development mode. And then I'll also specify target as web. This is not needed because the default target is web, but I will specify that just for the readability purpose. So this is basically telling Webpack to create a bundle for the project, and this will run on a web browser. And I will specify output, and there'll be an object, and I will specify a path, and there'll be path.resolve, and this is from the path module that we imported earlier. So path.resolve underscore underscore dir name, and we will tell Webpack where to emit that output bundle file. So in this case, we can have it emitted to, and this would be in a code, we can have it emitted to a dist folder, and inside that dist folder, Webpack should create another folder called client, and the output file will be emitted to this client folder, which is inside a dist folder. And we'll also give a file name for the bundle file. So the file name can be client underscore bundle.js, and we'll tell Webpack to resolve some of the file for us. So we'll do resolve, and this will be an object, and we'll specify the extensions, the file extensions that should be resolved by Webpack. So this will be an array, and inside that array we'll specify the file extensions. So there'll be js and .ts, and also .tsx, and also .jsx. So Webpack will resolve the files with these extensions. And then I will specify a module, and this is where we will utilize some of those packages that we installed, like TS loader, Babel loader. We can actually write the configuration in this Webpack file. So I will write a set of rules that will be an array of object. So I'll do test, so, and make sure the syntax is correct here, and that will be ts or tsx file $/ and I will tell it to exclude node modules because we do not want Webpack to look at any of the folders or files in our node modules folder. And we will use ts loader, put a comma there. So this 3 line of code is basically telling Webpack that, hey Webpack, if you see any files ending in .ts or .tsx extension, then use the ts loader in order to deal with those files. And also do not look any files inside that node modules folder. That's why we do the exclude. So we'll do the same thing with the js and jsx file also. So I'll just copy that and paste that. And instead of ts, I'll write js. Instead of tsx, it'll be jsx. And again, we're excluding node modules, basically telling Webpack not to look at node modules folder. And instead of ts loader, because ts loader can only handle ts and tsx files, or they will basically convert ts and tsx files into a valid JavaScript file. So to handle js and jsx file, we'll actually use Babel loader. And instead of doing this, we will actually need to specify some of the options. So we'll do loader will be Babel loader, and we'll also specify options so that we can actually use this Babel preset env, Babel preset TypeScript, and Babel preset React, because these are the presets that we actually installed earlier. So we will need that options, and there'll be an object, and we'll specify those presets. So that will be it, babel/set-react, and also let's specify Babel preset env first, and then we'll specify Babel preset React, and then we will specify that Babel preset TypeScript also. That, and then we'll just don't forget to put the comma there. And since we have the style and css loader installed, so we'll need to make sure that Webpack knows about the styles in our application also. So we can create a new object there, and then test, and then that will be any css files, handle it with the style loader and css loader. And also let's exclude the node modules folder just in case. Usually node modules folder might not have css files in it, but just to be safe, we'll just exclude the node modules folder so that Webpack does not look at node modules folder. So that will handle any style for us, and also make sure that when you are specifying this to package that we installed, the style loader should always be included at first, and then only the css loader. So if you put css loader at first, then it's not going to work. You're going to get some errors probably. So just make sure that you put style loader in the beginning and then the css loader. So let's also deal with some of the like font files. Maybe you want to add image to your application. Let's deal with that also. So we'll do test and we'll tell Webpack to deal with PNG file or SVG files or maybe TTF file, which is a font file, and any files ending in this extension. Will specify the type as asset/resource, and then Webpack will automatically handle the font files and any of the image files that you have. And this asset/resource is actually new to Webpack 5. Before Webpack 5, you would have to use the file loader or the URL loader to handle files, but with Webpack 5, you can just specify type as asset resource, and then Webpack will automatically handle it for you, and you do not have to install those two unnecessary packages anymore. So that's a little easier. So that should be it for the Webpack configuration. So the next thing we'll do is we'll create this source folder, because we have told Webpack that the entry point is inside this src folder, and there's another folder inside that is a client folder, and then there's a file called index.tsx file, which is the entry point. So we will need to create those folders and create the index.tsx file. You might be wondering about the error in this tsconfig.json file. So this error is basically complaining that it cannot find the src folder because we do not have it yet. So we'll now go ahead and create that src folder, and I'll create that in the root directory. And inside that src folder, remember that we have specified that there is another client folder inside that src folder. Let's create another folder inside that, and we'll call it a client. And then inside that client folder, we'll create this index.tsx file, and that will be the entry point. So in this index.tsx file, we will import React, and that's not correct. That's a common JS syntax. We want to use the ESM or the ECMAScript syntax. And it seems like there's a warning and error. The warning is React is declared, but its value is never read. We will use React later. But the error is coming because it says that can only be default imported using the ES module interop flag. So this error is coming from TypeScript. So let's go ahead and include that ES module interop property in our tsconfig.json file, and we can include that right under that JSX property. So we can do ES module interop. We can set that to true and save that file, and that error should be gone. As you can see that error is gone. Let's close that tsconfig.json file. And then I will import create root from React DOM/client. And it seems like it's giving us an error. So it is complaining that we do not have this module type/React DOM installed. So that's why we are getting that warning. And we actually did not install that. We installed types/React only, and not the type/React DOM. So let me see where that is. So we installed Babel preset React. We installed TS loader. Yeah, we installed types/React. We never installed types/React DOM. So let's go ahead and install types/React DOM, and we'll install that as a development dependency, and that'll be types/React-DOM. So let's go ahead and install that, and in package.json that should be installed as a development dependency, or about right here. Yeah, so now we have that installed. So we should not be getting that error, and that error is gone. And let's also import app, which we do not have yet, but we will create an app component shortly. But let's just import that for now, and it is giving us an error because it cannot find that, but we'll create it shortly. And over here we will declare a variable called root element, and that will be document dot query selector, and we'll specify an ID, and we have not done this yet. We will do that in the index.html file that we'll create later. So we will, the ID, we can set it up as root. So once that's done, and we'll see if that root element with that ID root actually exists, and if it does not exist, if not root element, then we will show new error, and we'll say cannot find root element with that ID. And then we'll say const root is equals to, we'll use that create root that we imported, and we will supply that root element as the argument. And then we will just do root.reender. We're basically re-rendering the application, and we will also use strict mode so that we get any so that it's easier to read any errors that we get, and we will just re-enter that app component there. So once that's done, let's go ahead and create this app component. So I will create this app component inside the client folder. So I'll create a new file called app.tsx, and in this app folder I will import React, and I will just create a new component called app, and I'll use an arrow function for this, and I will just return a heading tag saying hello world, and I will just export default that app component. So once I create this app component, the index.tsx file should not have any error anymore. So the next thing we need to do is that if you look at this index.tsx file, it is trying to grab that root element with an id root. So let's actually go ahead and create the index.html file, and then we'll just write a simple HTML here. And if you're wondering how I did that, in VS Code you can actually just type in exclamation, and if you hit tab, it'll automatically generate that HTML template for you. And then we will give this web page a name. We'll call it React from scratch, and inside the body tag we will create a div with an id of root, and this id need to be root because in index.tsx we are trying to grab a div element with an id root, so it needs to be the same. If it's not the same, then it will actually throw an error saying that cannot find root element with that id. So once that's done, that would be it for the index.html file. Now we can go to package.json and actually try to run the server and see if our app component is rendering. So in scripts, I will write a build script so that Webpack will build our project and create a bundle, and we'll also write a start script in order to run the development server. So the first script will be a build script, and this will be built using Webpack and config and the Webpack configuration file name, that is webpack.config.js. We'll also write a start script in order to run our development server, the Webpack server. I'll do test as open, and once we have that, we are actually ready to, and let's just remove that test script because we have not written any test. We don't need to run that. So once that's done, we can now, I think, start the development server and see if it works. If it does not, we'll make the necessary corrections. So we'll do npm. We'll actually need to run the build first, because if you look at the webpack config.js file, we have asked Webpack to create a bundle file called client bundle.js and put that bundle file inside a dist folder, and inside that dist folder there will be another folder called client, and that's where this client bundle.js file will reside, inside the client folder. So as soon as I run this npm run build, Webpack will create a dist folder in the root directory, and that dist folder will have another folder called client, and then inside that we'll have a client bundle. So let's go ahead and run that npm run build and see if we get any errors. It seems like we did get an error. It is complaining that Webpack has been initialized using a configuration object that does not match the API schema. It has an unknown property extension, and these properties are valid. So extension, and that should have been extensions. So in our webpack.config.js file, in resolve an extension, that should have been extensions. So let's make that correction, and let's run the npm run build again and see if we get any other errors. And it seems like we are getting an error. It says that module build failed and TypeScript emitted no output for this index.tsx, and that could have been the tsconfig file or our TypeScript configuration. If we come to tsconfig.json, we have set this no emit to true, so I think this is what's causing the problem. But if we look at it, it actually did create the dist folder, and inside that dist folder there's a client folder, and inside that client folder there's a client bundle. If we open that bundle, there's not much in this bundle file because it is actually throwing an error. So let's go ahead and fix this. In tsconfig, let's remove that no emit altogether, and let's come down here and run the build again and see if it runs. And it looks like that did run. It did create a client bundle.js, and if we look at it again, This file should be a little longer. Yes, so the Webpack did create a bundle file for us, and that's our client bundle. And remember that you are seeing all these comments because we have set in webpack.config.json, we have actually set the mode to development. That's why you see all these comments here. So let's close that and let's run the server and see if our app component is being rendered. So we'll do npm run start. So it seems that our server is running. It's running on port 8080. So let's go ahead and see if our app is rendered. We'll go to localhost port 80, and we are getting an error. It says cannot get, and it seems like a server error. Failed to load resources. The server responded with a status of 404 not found. So this might be happening because if we come to our index.html file, and this is our HTML template, this HTML template does not know anything about our client bundle. So that might be the reason why this is happening, because in our Webpack configuration, we have not told Webpack that we have a file called index.html, which is a HTML template. And also in index.html, there is no way that this index.html knows about this client bundle that is automatically created by Webpack. So what we can do is we can install a package called HtmlWebpackPlugin. This HtmlWebpackPlugin, it automatically creates the HTML files for us, and it also injects the link to the client bundle.js in the HTML. So let's go ahead and install the HtmlWebpackPlugin. Let's open package.json so that we know what's going on here in the background. We'll save this as a dev dependency as well. So we'll do save dev, and that is called HtML-Webpack-plugin. So once that HtmlWebpack plugin is installed, we now need to tell Webpack to use that plugin. So what we can do is right under this output, we can specify the plugins array, and we'll say new. Let's actually just import that HTML Webpack plugin. So we'll do const HTML pack plugin is equals to, and we'll just require that HTML Webpack plugin that we installed. So we'll do HTML as Webpack plugin, and now we can use this HTML Webpack plugin here. So new HTML Webpack plugin, and then we will supply the template, our index.html template. So we'll write a path to that. So that's under src folder, and inside that src folder there's a folder called client, and inside that client there's a file called index.html. So once that's done, let's save that file and let's build the application again. And let's now start the server, and our server is running. So if we refresh the browser, that is taking a little bit of time, but it looks like our application is running. The app component is rendering hello world. So the next thing we would like to do is to make our development environment a little simpler. Let's say that if you make any changes to your configuration files like webpack config or tsconfig, then what you would have to do is in package.json, because we have two scripts, one to build the application and the other one to run the Webpack dev server, you would have to manually run npm run build in order to build your application, and then you would have to manually run npm run start again in order to actually start the dev server. So that process can actually be automated. So we'll be installing a package called npm run all. Let's install the package first, npm install, and we will save this as a dev dependency too. So there'll be npm run all and npm run dash all. And what this package will do is, in one command, we can actually combine both of these commands in one command, so that we would not have to run two commands manually in order to actually build the application and run the server. So this command, this package, this npm run all, it'll help us run multiple scripts at once. So that's all this package does. And once this package is installed, let's make sure that it's actually in our dev dependency. And there it is. I have version 4.1.5 installed. So over here in scripts, what we'll do is we'll make a new script called dev, and this will run npm run all, and we'll supply a -s flag in there, so that s stands for sequential. So we will run both these scripts, the build script and this start script, sequentially. So the first thing we'll run a build script, and then we will run start script, and we'll just save that. So with that script there, let's actually just delete this folder entirely. So with that dist folder deleted, let's actually run that dev script and see if our application is, if the Webpack is building our application, and then let's also make sure that our application is running, the development environment is running. So let's do npm run dev. So it is looking at a webpack.config.js file. That's our configuration for the Webpack, and it should build the application. It looks like it already built the application, and it is now starting the server. And because we have used Webpack dev server, that's why we also see that it automatically opens the browser and it automatically opens the page, and it also has hot reloading enabled. So with that being done, we just had to run one command, and that is npm run dev, and we could run just both npm run build and then npm run start with the same command. So with that npm run all, I think that's, so we're all set up for the front end. There's a few more things we would like to do. Let's make sure that, because we have actually return a rule in order to handle CSS file, let's also make sure that our styles is working, and then after that's done, we will make sure that our font is working as well. So in order to test to make sure that our styles is working, is what I'll do is, inside client folder, I'll create a new folder called assets, and inside that assets folder, I'll create another folder called styles, and inside that styles folder, I'll create a new file called style. I'll say style.css, and I'll just write a simple heading tag here, and I'll give it a color of, let's give it a color of green. And in our app.tsx, we have used h1, and let's just import that style.css in our app component. So that's under, I'm currently in app.tsx, so that's only one folder back, and that's inside assets and inside styles, and that should be style.css. And let's see if the change is reflected, because we have used the heading tag, h1 tag, and then we have provided the h1 style as green, so that should be reflected in the application. Let's go ahead and verify that, and it looks like our CSS is working. So this was pretty simple. Let's also make sure that our font, that our Webpack is actually handling fonts too, and because that's where I think some of the people get confused. So let's go ahead and create another folder here. Inside assets folder, I'll create another folder called fonts. Let's go to Google Fonts, and then we'll just download some fonts, any fonts that you like. In my case, I will download the font that I like. So I'll search for a font called Rajdhani. Let's just download this entire folder and open that. And let's say that if I would like to use a bold font, and this is a TTF font, so I'll just copy that font, and then I will, should be here, and then inside src, inside client, assets, fonts, I'll just paste that font file in there. So we now have the font file in our fonts folder. So the next thing we'd like to do is we'd actually have to write a font face declaration. So I'll do font face, and font family will be, in my case, it will be Rajdhani at medium. So whatever font file that you are using, or whatever fonts you are using, make sure you write the same name. And for the URL, we'll just specify your URL to that font file. So that's inside fonts folder, and that'll be the font name, that's Rajdhani bold. And we'll also supply a format of true type, because it's a TTF file. The format will be true type. And let's come down here to the h1 element, and we'll also give it a font family. And once we save the application, it's already building it. I think that would work. Let's go ahead and try that and make sure that it's working. And it is already recognizing that font. And if we just inspect the element and go to console, and we see that the font family is being reflected in our application. And there's another way we can do this. So instead of posting your own font file in your own application, there's another way, or at least a better way, that we can do this. So instead of putting this font file in the fonts folder, what we can do is we can just completely get rid of this. So the completely get rid of the fonts folder, and then we don't even need to write the font declaration as well. And we don't even need to write a configuration in our Webpack file in order to handle fonts. So in order for any, let's say that we just remove that TTF, and we do need to handle images and PNGs and SVGs, JPEG, and all that images. And what we can do is just in style.css, we can actually just directly import that font, and Google provides a link. So we can just copy this, and then just paste that there, and we can just directly import that. And right now it is importing a font with a font weight of 700, so that's a little bit of bold. And then we will just specify the font family as that. Put a code in there, and I think that should work. Let's go ahead and see if that's working. And it is working. It does look like it's working. And then you can see that our font family is just Rajdhani and not Rajdhani bold. So there was two ways to handle fonts in our configuration. One with the configuration in the Webpack configuration file and serving the font file locally from your computer or from your project. And the other one was to use a CDN and just import the font from Google Fonts and then use it in the application. And that way we didn't have to write more code. And also we are not utilizing a lot of memory by including that font file in our application. I think this video is getting too long already, so I'll try to wrap it up soon. But there's one last thing that I would like to show you guys, and that is with TypeScript, because right now we do not have any TypeScript code anywhere. We just wrote a simple app component that does not have any TypeScript. So let me just quickly show how we can write some TypeScript code and also make sure that our application TypeScript is working in this application, because that was the main purpose of this video. So what I'll do is, in the client folder, I will create a new folder called components, and inside that folder I'll create a new file called a typography.tsx, and in this file we'll write a simple typography component that will just render some h1 element or h2 element provided some props. So the first thing we'll do is we'll import React. We'll write a type declaration, so I'll do typography is equals to, so we'll do react.html attributes, and we're doing this in order for the typography component to accept any attributes, any HTML attributes that a heading tag, maybe h1 or h2 tag, accepts. And that'll be HTML element, and so we'll just write a simple variant, and that can be optional. So the user can supply a variant of either h1 or h2 for now, and then we'll also supply a children, because the heading tag will have children, and children should not be optional because we do not want an empty heading tag in the application. So the children is not optional, and this question mark in here, that simply means that the variant is optional, and you can provide some default variant. In children will be react.react node, so that'll actually be a React node, and we'll just declare a typography component. Typography is called stu, and that will take variant and children, and that's from typography props. And let's just quickly export that also, called typography, and we can just return, let's return a React fragment there so that we do not have any unnecessary div. So in here, if the user supplies a variant of h1, then we'll return an h1 element, and if the user supplies the variant of h2, we'll return an h2 element, and we'll also let the user provide any children that they want. So we'll do if variant is equals to h1, then we'll return an h1 element with whatever children, else we'll just return h2 element, else h2. So that's just a very simple typography component. So let's import this typography component in our app component and make sure that it's working. So the typography component is imported, and let me just get rid of that, and then we'll just use that typography component, and you'll see that VS Code already provides this autocomplete feature because we have TypeScript enabled, and because we have used TypeScript, this is already providing the available variant that the typography component will accept. So in this case, we have defined that the typography component will accept two variants, and that is S1 and S2. And we can see that whenever we are using that typography component in our app component, we get that S1 and S2 option. So that makes the development a little bit faster. So in this case, we'll just use S1, and then we'll just say we entered H1, and let's save that. It have been H1, and there it is. And if we, because we variant is optional because we have put that question mark in there, so if the variant is not provided by the user, then we'll just re-enter a h2 tag. So let's not provide the variant at all, Let's actually first make sure that it was actually rendering h1, and it is rendering h1 here. And if we do not provide any variant, let's set that, and this should render h2 tag, and it is rendering h2 tag, and there it is. So that was a very simple typography component. So you can always extend this project. You can uh, write more components. You can do a lot of things with this. And we have not done anything with the backend yet, because this is all just the client side code. And same with the Webpack configuration. If we come over here, we have specified the target as web. And again, this is optional. This is the default target is web. But if we are writing some server-side code, then we need to specify target as node, so that Webpack can handle our node application as well. And then, yeah, the configuration would have been totally different. And if you'd like to see me do that video, probably make some crowd application, then let me know down in the comments below, and I will try to make a video about that soon. And if you have any questions, any suggestions, any advice, I've only been doing YouTube for just over 3 months now, and I'm still trying to come up with new ideas, come up with new videos, new tutorials, or new courses. So let me know if you wanna what you would like to see. And thank you for your time. Thank you for watching, and I'll see you in the next one.